Imagine dealing with a really serious nerve injury. The recovery, well, it can be incredibly long, often painful, and frustratingly, even with the best doctors, you might not get back to how you were. It's like your body's communication lines are down and reconnecting them is just tough. But what if I told you there might be a way, something simple you could do every day at home that could seriously speed up that recovery and maybe even improve the outcome? Welcome to the Deep Dive. We're here to cut through the complex science jargon and bring you fascinating research straight from the labs, making it clear and relevant for you.
Exactly. We're all about giving you solid, science-backed insights, minus the dense academic speak. We dig into studies from top places to help you see what's really going on.
And today we're unpacking a pretty amazing study. It suggests that electrical muscle stimulation, or EMS, could be, well, a bit of a game changer for nerve injury recovery.
A really interesting approach to boosting the body's own healing.
So let's set the scene first. We're talking about peripheral nerve injuries. These aren't in the brain or spinal cord, but the nerves connecting out to your limbs, your organs.
Yeah, the communication network, basically.
These injuries can be brutal. Think workplace accidents, bad sports injuries, maybe even deep cuts. Thousands of people every year end up struggling to get back full movement or strength.
It's a huge impact, not just physically. It really affects quality of life. Your nerves are like super complex wires, damage them, and the signal to the muscle gets lost.
And current treatments, like surgery.
Surgery's come a long way, definitely. Surgeons can do amazing work reconnecting nerve ends. But honestly, we've kind of hit a plateau. Meaning, even with great surgery, full recovery isn't guaranteed. The nerve still has to regrow, sometimes over long distances. And while that's happening, the muscle isn't getting signals. It's denervated.
Right, and that leads to muscle wasting. Atrophy.
Exactly. And if that goes on too long, the muscle damage can become permanent. The nerve might eventually get there, but the muscle can't respond anymore.
So surgery alone isn't always enough. The body needs more help. Which brings us to the big question researchers in Toronto asked.
At the Hospital for Sick Children, yeah. They wondered, what if we used electrical muscle stimulation, EMS? Could a daily dose help those nerves reconnect better, faster?
Could it sort of guide the nerve back to the muscle?
That's the core idea. Could EMS make that healing process more efficient?
Okay, so how did they test this? You can't just zap people randomly. They needed a solid experiment, right? One that relates to real patients eventually.
Precisely. They used rats, which are a standard and effective model for this kind of nerve regeneration research. They performed surgery to repair the tibial nerve that's a major nerve in the leg, so a controlled injury model.
And then the EMS part.
This is where it gets really interesting. They didn't just blast the muscles. They designed what they called a clinically realistic EMS paradigm.
Okay, what does that mean in practice?
It means 600 muscle contractions per day, but delivered in manageable 1-hour sessions.
Only an hour.
An hour a day, 5 days a week. And they kept this up for as long as 3 months. Then, the crucial part, they compared this group to rats that had the surgery, but no EMS.
A control group. Standard stuff.
Right. And the choice of moderate stimulation was deliberate. Some earlier research hinted that too much, like constant stimulation, might actually be bad. Overwhelm the system.
Ah, okay. So less is more, maybe.
Or at least a specific amount is more. They were aiming for something practical, something a patient might realistically do at home someday, maybe with a small, portable device.
That makes sense. Not some heavy-duty lab equipment, but something accessible.
Exactly. A thoughtful approach. And the results they got? Well, they were pretty striking.
Okay, let's get into those results. You mentioned they looked at motor units. Remind us what those are again.
Right. So a motor unit is basically one nerve fiber, one axon coming from the spinal cord, and all the muscle fibers it connects to and controls. It's the fundamental functional unit. Your brain sends a signal down that nerve fiber, and boom, all those connected muscle fibers contract together.
Gotcha. So more motor units means more connections are working properly, more control, more strength.
Precisely. It's a direct measure of how well the nerves have reinnervated the muscle, how many successful connections have been reestablished.
And what did the numbers show between the EMS group and the no EMS group?
The difference was really stark, and it grew over time. Get this. After just 1 month, the EMS group already had 37 motor units back online.
Okay, and the control group?
Only 22, so a noticeable difference early on.
But it didn't stop there.
Not at all. By 2 months, the EMS group leaped to 104 motor units.
Wow, 104 compared to
Compared to just 57 in the control group. nearly double the connections.
That's a huge gap opening up.
It is. And then the 3-month mark, this is the really incredible part. The EMS muscles reached 142 motor units.
142, how does that compare to normal, like an uninjured muscle?
That's what's so amazing. It's almost identical to normal uninjured rat muscles, which typically have around 155 motor units.
Wait, really? So 3 months of this 1 hour a day stimulation got them back to near normal levels of nerve connection?
Pretty much, yeah. Meanwhile, the surgery-only group, they were lagging way behind at only 81 motor units, less than half of what the EMS group achieved and far from normal levels.
That is genuinely stunning. It's like the EMS wasn't just helping, it was putting the healing on fast forward and getting it almost all the way back.
It suggests a fundamentally different recovery process is happening with the stimulation.
Okay, incredible numbers on the nerve connection.
Same.
But did it actually make a difference in how the animals moved? Did they function better?
That's always the key question, isn't it? Cellular improvements are great, but function is what matters to a patient. And yes, it did translate.
How did they measure that?
They used skilled walking tests. One key test involved having the rats walk across a narrow tapered beam, kind of like a balance beam challenge.
Okay.
And the EMS animals performed significantly better. Specifically from week 6 onwards, they had fewer slips off the beam. They were more stable, more coordinated.
So they weren't just better wired up, they could actually use their leg more effectively for a tricky task.
Exactly. It showed the improved reinnervation was leading to real functional gains in motor control.
Now, I remember you mentioned something interesting earlier, that another type of walking analysis didn't show quite the same big difference initially. What was going on there?
Yes, that's a great point and really highlights the subtleties of this kind of research. They also used a standard walking track analysis, looking at things like paw prints. Initially, the differences weren't as dramatic there.
Why not?
While the researchers noticed the rats were clever. In the early stages, rats in both groups developed this compensatory strategy on the tapered beam. Instead of trying to step normally and potentially slipping, they would kind of slide their injured paw along the beam.
They learned a workaround.
Exactly. A clever adaptation that actually masked the underlying difference in their ability. It made both groups look a bit more similar on that slip measure at first.
But that didn't last.
No. As time went on, and presumably as recovery progressed or they got more confident, that sliding behavior decreased. And that's when the EMS group's superior ability to avoid actual slips really shone through, especially from week 6.
So the underlying functional recovery was better in the EMS group. It just took a specific test and looking past the initial compensation to see it clearly.
Precisely. It really strengthens the finding, actually. Even with the animals compensating, the EMS group ultimately demonstrated genuinely better functional recovery. It shows you need to look closely at behavior in these studies.
Fascinating. Okay, so we have faster, near-complete nerve reconnection and better functional movement. What does this tell us about how EMS might be working its magic? It's more than just keeping the muscle from wasting away.
Oh, absolutely. It's not just passive preservation. The study suggests EMS is actively promoting and improving the whole regeneration and reconnection process. There seem to be a few key things happening. Well, first, EMS seems to boost axon outgrowth right at the injury repair site. The axon is the long wire part of the nerve cell. EMS might be encouraging these axons to grow faster and more purposefully towards the muscle.
Like giving them a nudge in the right direction.
Sort of, yeah, and maybe speeding them up. Second, the muscle contractions themselves, triggered by EMS, likely cause the muscle to release beneficial chemicals called neurotrophic factors.
Growth factors for nerves.
Exactly. Like fertilizer for the growing nerve axons. It makes the muscle a more welcoming target, promoting nerve survival and growth.
Okay, so better nerve growth and a more welcoming muscle.
And third, EMS actually seemed to improve the structure of the connection points, the neuromuscular junctions, or end plates. These are the critical sockets where the nerve plugs into the muscle fiber.
So not just more connections, but better quality connections.
That seems to be the case. More organized, more effective junctions, leading to better signal transmission from nerve to muscle.
It's a multi-pronged effect, really. Wow. So better growth, better environment, better connections. It's a comprehensive upgrade to the healing process.
That's what the evidence suggests. And think about the implications. This idea of a moderate daily EMS routine, if it can be done at home, affordably, that's potentially revolutionary for rehab.
Taking some of the burden out of the clinic, making effective therapy more accessible.
Exactly. And there's another really crucial finding related to the quality of nerve regrowth.
Oh, What's that?
The study found that EMS significantly reduced something called terminal sprouting.
Terminal sprouting. Sounds a bit technical.
Yeah.
What is it and why is reducing it good?
So when nerves regrow, sometimes they branch out excessively and in a disorganized way near the muscle target. That's sprouting. While some branching is normal, too much disorganized sprouting can be a problem.
How so?
It can lead to nerve misdirection or synkinesis. This is where a signal meant for one muscle accidentally triggers another one nearby because the wiring got scrambled during regrowth.
Like you try to do one thing and something else happens involuntarily.
Precisely. You might try to smile and your eye twitches, or you close your eyes and your mouth moves. It happens because the nerves didn't reconnect selectively to their original targets.
That sounds incredibly frustrating.
It can be. So by reducing this excessive disorganized sprouting, EMS seems to promote a more selective and effective reinnervation. Nerves find their correct targets more often.
Leading to cleaner, more coordinated movement. Not just stronger, but more precise.
That's the implication. A higher quality of functional recovery, not just quantity. Better control, less unwanted movement.
This is incredibly promising. The potential to not just speed up recovery, but also improve the quality and reduce frustrating side effects like synkinesis.
Yeah.
That's huge for patients.
It really is. It paints a picture where EMS isn't just a temporary fix, but something that fundamentally guides a better, more complete healing process.
Now, this was an animal study, a very promising one. What are the next steps to see if this translates to people dealing with nerve injuries?
That's the critical bridge to cross. Animal models are essential, but human physiology is more complex. Researchers need to carefully figure out the optimal parameters for humans, the right intensity, frequency, duration of EMS.
It might not be exactly 1 hour, 600 contractions for us.
Probably not exactly, no. Our nerves regenerate differently, muscles are different sizes. We also need to know the best timing. When should EMS start after surgery? Too early might interfere, too late might miss the window.
And does it work for all types of nerve injuries?
Another key question. This study looked at a specific nerve repair. Would it work as well for, say, nerve compression injuries or more complex injuries like brachial plexus damage? More studies are needed.
And then there's the practical side for at-home use.
Absolutely. Patient compliance is huge. Devices need to be safe, effective, and crucially easy for people to actually use consistently at home. Plus, navigating the regulatory pathways to make approved therapies available.
Lots of steps, but the potential payoff seems enormous. Moving recovery towards being more patient-driven, more effective.
Definitely. It offers real hope. And this is where the potential application of technologies developed by companies like Fit becomes really relevant.
How so?
Well, this study highlights the benefit of a consistent, potentially at-home, moderate EMS routine. Fit, being Australian-owned and operated, focuses specifically on muscle stimulators enhanced with EMS technology. Their Fit Ultimate devices, for example, are designed precisely for that kind of scenario: portable, mobile, easy to use regularly.
So they fit that model of accessible, user-driven therapy the study points towards.
Exactly. It's about empowering individuals with tools based on solid science, tools they can integrate into their daily lives. Whether for recovery support, like in this study's context, or even for general muscle maintenance and wellness, that commitment to effectiveness and accessibility is probably why they've received awards like Best Product of the Year from productreview.com.au for both 2024 and 2025.
And you mentioned they focus on making the science understandable, too.
Yeah.
Yes, that's a big part of their approach. They offer a research digest on their website. They take complex, peer-reviewed university studies, just like the one we've been discussing, and break them down into plain language.
That's fantastic, so people can actually understand the science behind the technology they might be using.
Precisely. And they always link back to the original study, so if you want to do your own deep dive, you can. It aligns perfectly with what we try to do here, making science accessible so you can make informed decisions about your health and wellness. Knowledge empowers you to ask the right questions.
What a fascinating deep dive today. This research on EMS really does open up exciting possibilities for improving nerve injury recovery.
It truly does. The idea that we can use targeted electrical stimulation to significantly accelerate healing and restore function to near normal levels in just a few months, it's incredibly hopeful.
It suggests we can actively guide the body's own repair mechanisms much more effectively than we thought.
And that accessible at-home solutions grounded in good science could make a massive difference in people's lives after these often debilitating injuries.
So if this conversation sparked your curiosity about EMS, nerve recovery, or just how science is being translated into real-world wellness tools, definitely check out resources like the Orium's Fit website and their research digest.
Understanding the why behind these technologies is so important.
Absolutely. Don't miss our future deep dives. Follow us on Spotify. Maybe leave a review if you enjoyed this, and share with anyone else who loves getting into the science behind health breakthroughs.
We love hearing your thoughts too, so feel free to comment.
Definitely. So until next time, keep exploring, keep learning, and maybe keep wondering, how else might we harness the body's electrical systems to unlock even greater healing potential? Keep wondering.